assignment, inverse of a line, we're going to review briefly what a linear function is with slope and the y-intercept. And what I want you to do is not to copy the numbers that you see here. After I am done explaining, then you will create your own function, and then you will plot your own function on the paper. So I was going over what slope is, and the slope is the ratio of the rise over run, also known as the difference in y divided by the difference in x. And the formula for slope, it is y2 minus y1 divided by x2 minus x1. We could also use the delta symbol because that implies change. So the change in y divided by the change in x. So the slope, which is my blue number here, it is -2 over 3. And going by the definition of slope, we know that we're going to have a point, and then from that point, the constant rate of change will be 2 units down and 3 units to the right. So what I'm going to do is use the y-intercept. And since it is the y-intercept, it is on the y-axis, and we already established that any point on the y-axis will be called y-intercept, right? So if it is on the y-axis, what will the x-coordinate be? 0. So the coordinates of the y-intercept will be 0, 5. So I'm going to plot that point. And of course here you could just select random numbers for x and then plug them into the equation and find the y values. Or you could graph it using the y-intercept and then the concept of the slope. So we already said the slope is -2 over 3. So I'm going to go from the y-intercept 2 units down and 3 to the right. Again, 2 units down and 3 to the right. 2 units down, 3 to the right. Now, just like I have -2 on the numerator, I could also have the negative on the denominator, and that has the exact same meaning, okay? It doesn't matter if the negative sign is on top or bottom, as long as it's not on both. Why would we say that? It cannot be in both. It will change it to what? If we have negative over negative? Positive, and we don't want that. So if I use this form, this tells me 2 units up and 3 units to the left. So let's see if this is true. Again, from the y-intercept, so I will go 2 units up, 3 to the left. 2 units up, 3 to the left. So you guys see it will give us the same set of points. So I'm going to trace a line, connect the points because I'm talking about a linear function, and we know those are continuous, right? So now what I want to do is I'm going to select the x values. So I will have -6, and I'm just going to use, for convenience, I'm going to use points where the x and the y values are integers. So -6, -3, 0, 3, 6, and 9, and that should be enough. Now, I want Ashley tell me what will be the y coordinate when x is equal to -6. 9. Very good. Mara, when x is equal to -3. 7. Okay. Isaac, Brandon, when x is equal to 0, oh, that's easy. 5. And Amy, when x is equal to 3? 2. 3. Okay. Edwin, when x is equal to 6?
1.
And Julio, when x is equal to 9?
-1.
-1. Okay. So now what I'm going to do is I'm going to graph the inverse of that function. And I'm going to do that by interchanging the x and y. We've been doing a lot of that, right? So it should be easy by now. So 9, -6. 7, -3. 5, 0. 3, and 3. 1, 6, -1, 9. So now I'm going to go and plot those points. So I will have positive 9, -6, positive 7, -3, 5, 0, 3, 3, 1, positive 6, and -1, positive 9. And then we connect them. Okay? So we can see that the two lines, and I'm going to refer to this one, the blue line, as f of x. And the equation for it, we have it there, is -2/3 x plus 5. Now, the inverse function, and we know it is the inverse because we interchange the x and y values, and also we can see that the line, it is reflected across this dashed line. What is the equation of that dashed line, or dotted? Y equals x, right, which is the identity function. So the equation for the inverse function, we're going to learn how to do that in a minute, but I can tell you that instead of using y, we're going to step out of that for a minute, and we're going to be using the notation for f inverse, which is that. Okay, so now what I want you guys to do is to create your own linear function. So you may choose any number for your slope and any number for your y-intercept. And if you want to use an integer for your slope, let's say you want your slope to equal to 4, then that will be 4/1. Okay? It could be positive, it could be negative, it could be whatever you want. So I would like for you to work with your partner who is either behind or in front of you. So you could just turn your chair and work on that problem. Now please get a piece of notebook paper, and the title for this will be Finding the Inverse Algebraically. And what I'm going to do is give you some steps to find the inverse of any function, well, almost any function. And so those steps will go in order from 1 to 4. We're going to revisit that function that you created in a minute, okay? So step number 1 is going to be to replace f of x with y. And we already established that f of x is just the function notation for the y value or for the output, correct? So they have the same meaning, but for the purpose of finding the inverse of a function algebraically, we cannot do it with f of x. So that's why we have to do it with y. If your function is already defined as y equals and then the function, then you skip the first step. Now step number 2 is going to be interchange x and y. So remember, we've been finding the inverse numerically, right, or graphically, by interchanging the x and the y coordinates. So we're going to do the same thing here, not with the numbers, but with the variables. Step number 3, we're going to solve for y. So what that means is that we're going to isolate y, which means we're going to leave y by itself. Now, once we have accomplished that, we move to step number 4, and that will be to replace the variable y with the notation for function inverse, which will be f inverse of x. Now, sometimes our function might not say f of x equals something. Sometimes it might say g of x or h of x or any other letter. So once you use inverse notation, just make sure that it matches the letter that you started with. Okay? So what I'm going to do first, the other paper that you picked up, the one that looks like this, it is called Function Inverses. So we're going to solve the example number 9. So example 9, I have a function h of x is equal to the cube root of x minus 3. So I'm going to start with step number 1. So I'm going to replace, in this case, not f of x, but h of x. I'm going to replace that with y. Now I move to step number 2, and step number 2 says interchange x and y. And this is a very simple step. Simply we replace y with x, and we replace x with y. We don't need to change the sign, we don't need to do anything to it, just change one for the other, interchange. Now we move to step number 3, and step number 3 says solve for y. Now I know that you might be used to doing things like plus 3, and then you cancel that. I prefer not to do that because sometimes students don't really know if they're adding or subtracting or dividing or multiplying, and also the equation becomes a little messy. And once we get to pre-calculus or calculus, we're going to be solving very complicated equations, and it will be impossible for us to do things like that. So what I prefer to do is think like this. What is this negative 3 doing to the y? Subtracting, right? So if I move that across the equal sign, it's going to change to its inverse operation. So what is the inverse operation of subtraction? Addition, right? So we will have x plus 3 is equal to the cube root of y. Now, I know that I need to leave y by itself, so what will be the inverse operation of the cube root? So I hear square. So if we have the square root, we will square it. And since we have the cube root, we cube it, right? So what I'm going, let me just write it on the next row. So if we raise this to the third power, or we cube it, we have to do it to both sides, and that will take care of the cube root because they're inverse operations, so one will undo the other. And so we end up with y is equal to x plus 3 cubed. Now we're done with step number 3, so we move to step number 4. And for step number 4, we replace y with f inverse, but we did not start with a function named f, right? What was the name of our function? H. So we're going to replace that with h inverse of x is equal to x plus 3 cubed. And if you were to graph that function, the inverse, h of x and h inverse of x, you could see that they reflect across the line y equals x. Now, if I write h inverse of x on the right side, will that be the same as this? Yes, it is the exact same thing.
Students, just a reminder, if you have received
From the same page, problem number 12, the handout called function inverses. So this function is g of x is equal to negative 4x plus 1. So step number 1, we replace g of x with y. Step number 2, we interchange x and y. So the y becomes x, and the x becomes y. Step number 3, we're going to solve for y. So we see that the plus 1 is adding to the y. If I move it across, it will subtract. So x minus 1 is equal to negative 4y. Now from here, what is this negative 4 doing to the y? There's no sign in between them. Multiplying. So if I take this across, what is it going to do? Divide, because division is the inverse operation of multiplication. So that will be x minus 1 divided by negative 4. It's very important that we keep the sign of the denominator, which is negative. So divided by negative 4. Now, this could be a valid answer. That is correct. However, if I was to ask you, what is the slope of that function, could you tell me quickly? Maybe not. So if we simplify it, x divided by negative 4 and negative 1 divided by negative 4. Maybe that could help us out. Well, x divided by negative 4 is the same thing, as negative 1/4 times x. So those two expressions are equivalent. And now, if we divide a negative over a negative, what do we get? Positive. So that will be positive 1/4. Now, could you guys tell me quickly what is the slope for this linear function? Negative 1/4. And the y-intercept is? As a point, the x-coordinate should be what? 0, because it's on the y-axis. And the y-coordinate is 1/4. Okay, but we were not doing that. We were finding the inverse, right? So let's go back. We already solved for y. Oh, did I skip a step or something? Oh, this was still part of step 3. I'm sorry. What were you saying? So that would be step 4, right? So step 4 will be to change it to function notation. What was the name of our function from the beginning? G of x, right? So we will use G inverse of x is equal to negative 1/4 of x plus 1/4. Okay, so let's do one more. Now we're going to do example number 10. So the function there, it is g of x again, and that is 1 over x minus 2. So step number 1, we replace g of x with y. Step number 2, we interchange x and y. Step number 3, we solve for y. And so, let's think about it. So what is this negative 2 doing to the y? Subtracting. So I'm going to take it across, change this to its inverse operation, so it will be adding. X plus 2 is equal to 1 over y. Now here, sometimes students get confused, they don't know what to do, but I want you to think of this before you panic. What is the y doing down there? It's dividing the 1, right? So if I take this across, instead of dividing, it's going to do the inverse operation, which is multiplication. So we multiply. And it's going to multiply everything inside that parentheses. Now, what are the y and the expression inside the parentheses doing to each other? Multiplying, right? So now what I need to do is take everything here across, And that will take care of the problem. 1 over x plus 2. Believe it or not, that was a question on my dual credit pre-cal exam. Some students didn't know how to answer. Pretty sad, right? So step number 4, now that we have solved for y, what is our last step? Change it to inverse notation, right? So g inverse of x is equal to 1 over x plus 2. Okay, we're going to do one more, and that will be the last one. Let me see the time. We have 2 minutes. We can do it. And so we're going to do number 11. So we have the function h of x is equal to 2x cubed plus 3. So step number 1, replace h of x with y. Step number 2, interchange x and y. Step number 3, solve for y. So again, this plus 3 is adding, take it across, it will be subtracted. Now the 2 is multiplying to the y, so if I take it across, what is it going to do? Divide. Now we have y raised to the 3rd power, or being cubed, right? So how can we undo that? We're going to take the, not the square root, the cube root. We do that to both sides, and that will, the cube root will undo the cube. In other words, they will cancel each other because they're inverse operations. And so the inverse function becomes that. Step number 4, we replace the y with the notation for function inverse. And that will be, we started with function h, so we will call it h inverse of x is equal to the cube root of x minus 3 divided by 2. And so this will be the end of the video. Now tomorrow, don't pack yet, tomorrow I will not be here. However, you are going to be required to finish that handout, function inverses, and turn it into the substitute. Not on the tray, the substitute. Okay? And I will be grading them.